second, I just need to change the presentation. Right. Alright. First of all, a few organizational things. Feel free to interrupt me during my talk. Because we are here in person, we have the opportunity to talk with each other. Even if you disturb the agenda of the presentation, personally, I feel that it can bring more benefits than cons, because at least we'll have it more energetic, and we basically I think that meetups should be more around discussions and knowledge sharing than just about giving a talk that you can later watch on YouTube. And I'm not afraid of being interrupted. And any questions? I might not answer your question. I hope that you understand it. And yeah, and the title, I hope you liked it. It was generated by ChatGPT. The description as well was generated by ChatGPT. Thank you. But right now it's not ChatGPT. I will be talking by myself. And who I am? I'm a Go and C# developer, basically. And right now, as Michał told, I'm an instrumentation developer for Splunk Observability, which is the product by Splunk for observability. And most 90% of my time, or maybe even more, I'm basically contributing open source to OpenTelemetry project, which is, as Michał said, one of the biggest open source project in general. And right now I'm an OpenTelemetry Go maintainer. There are I think right now 3 maintainers of OpenTelemetry Go. I'm also OpenTelemetry.NET automatic instrumentation maintainer, but I'm also contributing to specification and several other OpenTelemetry repositories. So basically I have some wide experience in OpenTelemetry, but because of this wideness, I also have sometimes problems with having specific questions, because when you learn something wider, then you do not know something about details. So that's why I may not be able to answer your questions, even regarding Go. Do you have any questions? Yes.
Yes, exactly what I wanted to say, because you are cut off in half.
I see. Thank you for your remark. Do you have any questions so far? All right. So the presentation will be divided into parts. First, I gave a similar talk, or kind of talks like this, 4 times, and I saw that there are 2 things which are welcome to be seen. One is the basics, the foundations about observability and OpenTelemetry, to get familiar with the vocabulary. That will be the first thing, and also have a demonstration of OpenTelemetry as a whole. And the second part will be about OpenTelemetry Go. So first, I will start with observability and OpenTelemetry basics. Here, this presentation will be shared. You can click on those hyperlinks. The first one is basically the OpenTelemetry webpage, which have maybe I'll just even show it right now. So there's a good, nice webpage, which is also open source, and you can edit if you find any bugs and you want to contribute. So you can find here documentation about OpenTelemetry, getting started, concepts. They are getting started for DevOps. So if you like reading more than listening, then maybe you can also read it. All right, going back to the presentation. So first question, why observability? Right now, I would say there's a big hype for microservices, cloud, and while everything is distributed and there are a lot of interactions between services, when something goes wrong, it's not very simple to grasp and find where's the root problem, where are the problems. Also, when there was the monoliths, it was easy to debug one application. Right now, when there's an interaction, you have multiple applications, and basically monitoring a single application doesn't help because you do not know how it does interact with other services. So, for instance, this is the architecture of OpenTelemetry demo. So I know it's very small, but also this is the reason. So some time ago, Google has created something which was called Hipster Shop. It was basically some kind of project to demonstrate, I think, GCP and capabilities, how to create a microservice architecture. And basically, in OpenTelemetry, there's a telescope shop, because here's the mascot of OpenTelemetry. The telescope is like the item which for OpenTelemetry. And so this is basic architecture for a telescope shop. So there are a lot of services, multiple languages. Here you can see on the bottom here. Sorry that my taskbar is hiding, but there are OpenTelemetry. You have basically microservices. You can have multiple languages, etc. So basically, what's observability? Need some help here.
Sorry, on your previous slide, you put something like monitoring is not helping, right? That was like the last one.
Yeah. So you want to know what's the difference?
I think so. Yeah.
So basically, this is like the I try to explain here, because monitoring is just something that you do that you just see like the CPU, etc. And observability is a more like abstract term, and observability is like a term which says that you are able to say something about your system based on the external output. So you have an observable system when you actually can answer questions getting from your monitorings, for example.
Okay.
By just getting the data doesn't mean that you can do anything. So basically, if you want to have something which is really observable, you need to understand how these people, relate to the system. So it's also like answering, the fact that you just use OpenTelemetry doesn't mean that actually you have observability. It's just, you need to often, for example, do some custom metrics, custom instrumentations, to be able to answer questions which you know that you can expect, or you are highly expecting. So, instrumentation produces this telemetry data, but you need to know how to query the data to answer the questions. If you do not know how to query the data, you do not know the data, you have no possibility to have observability. Does it somehow answer your question?
I think so. Yeah.
I know it's fuzzy, but basically it's like it's a buzzword a little bit, but basically it's about putting putting the stress that it's not only about the data, it's also about the ability how to use them. For example, to create dashboards. Dashboards are helpful to have observability because it gives you quick answers to your questions. Shall I go further? Any other questions? Am I speaking too fast because I'm stressed?
No, it's good.
It's good? Okay.
Yeah, okay.
Thank you. Okay, so so basically the most popular signals, which is the signal is a term called in OpenTelemetry, is a type of telemetry. It's called a signal. So basically, right now, the OpenTelemetry defines 3 types of signals: metrics, logs, and distributed tracing, or basically spans. And each of these, by design, can be structured so that they can have some correlation between all of these. There are also other signals that may come in the future. For example, profiling can be seen also a kind of telemetry data. And there are also some security events that may come in the future, but this is the current state of OpenTelemetry specification. Oh, I have forgotten to prepare one thing. So one of the key signals are metrics. So metrics basically are like the aggregations of some data, for example, CPU utilization, HTTP request counts, or it can be some buckets, cumulative histograms, like for example, some which requests were in the buckets between 8-10 milliseconds. There can be some request rates per second, etc. They can be even metrics grouped by some clusters, etc. So there are a lot of basically even the metrics there are a lot of complex, like the metrics data type is kind of complex model, which is also specified by OpenTelemetry. And maybe I can show you an example. So to demonstrate some things maybe in practice or more in a more visual way, there's an OpenTelemetry demo, and you can just git clone it and run it yourself. So this is So right now I'm running, I'll do demo effect, sorry. I wanted to run back in background so it doesn't pollute my output. Okay, so here's basically documentation for OpenTelemetry demo, and I just started it, and I just want to quickly show you the UI. I'm not sure if it will be ready yet. No. So I will do it like that I will proceed with the presentation, and I will show like the examples of metrics, traces, and logs later on. At least I will have less context switching. The next concept is tracing. Tracing, I don't know if I ever use, for example, tracers or trace in the command line to see, for example, when you do some network request that you want to know where a packet was in each endpoint. So there's basically a structure, like a parent child, for example. When you make an HTTP request, I was here for this many seconds, then I was in this service, etc. So you have a diagram. I do not have a nice picture right now because I will later show it on a visual presentation later. But basically, one of the most important things when you have instance is distributed contexts. So this is something which gives you possibility to correlate things which are happening between the services. So it's a kind of distributed a debugging system, I would say, that you have kind of information which is going through the whole lifespan of some request. Also, what is interesting in OpenTelemetry, the spans can have events. Events are basically logs which are contained in a single span. So we have, for example, an HTTP request which was, for example, taken for 1 second. But you can create, for example, you can give a point. Oh, here something happened, and you can put something like a structured log, basically, where you can log, for example, that something strange has happened, or I don't know, a product has been created, or any complex structured things. The last thing it's about logging. So logging, I think is the simplest thing. It's about basically something which is has a body, a message, and have some attributes, so it can be structured. And logs are often emitted to a standard error or standard output. And what is interesting for OpenTelemetry standpoint is that the logging and traces and span are also can be correlated. So you can have an information that you can, for example, group the logs by a trace ID or span ID. So you can filter out, for example, all logs which are connected to some span. Yeah, but now we'll check if Docker is alive. Jesus, I think my laptop is underperforming when I'm sharing on Zoom.
That's why I'm scared to doing demo live.
I'm always doing a demo live. Always something is going wrong, but it was never that wrong. from scratch. Should go well. This I have problems with RAM. Yeah. Okay. It will run in the background. Now I can only say that sorry that I haven't started it before the presentation, but I think we have forgotten because of the stress. So I will just make something else. Concepts, I hope there will be something here. So just to have a visualization of traces, I hope there will be something here, but I'm not sure. Even my browser is very slowish. So this is improvisation. So, like, I just wanted to show that this is like an example of a span, that you can have multiple services which have some units of work and you can see how they're related. So basically, this one on the top is the most current one. So we can see that some service was started from the front end, and the front end has some unit of works, but then it reaches also other services, like something called driver, which is, and then the Redis, and basically that all of these things are like connected to each other. And I think I'll go back to the presentation because, yeah, basically I think I have problems with my machine, that it has not enough RAM. Yeah. So, how you can do that? Achieve like this kind of like system to have this thing. Like you need like three things. You need to instrument your applications to get this data, this spans loaded metrics. Then you need to send it somewhere, and you need something to visualize them. And OpenTelemetry helps you in achieving the first bullet point, which is something to instrument your application that it will generate telemetry data. So OpenTelemetry is like the second most active project in CNCF. Michał said that it is second biggest, but according to the number of commits, it's the fourth biggest CNCF project. It has contributions from 75 companies like Google, Lightstep, Splunk, etc., Microsoft. So basically, it's a project which has a lot of contributions, and it is like not something which it is like a live contribution. These are things which are basically happening right now. And what I wanted to one of the most important things of OpenTelemetry is also why it was so many companies are involved, is that it is by design vendor agnostic. So this is like a standard which other companies try to adhere to, and not the other way, that you have some telemetry that just only works with one vendor, like, I don't know, Splunk, Datadog, or whatever. So you produce telemetry that you can then later use in multiple systems. So what OpenTelemetry creates? One thing is that it creates, it's about specification. So it creates it specifies how the API, there are two kinds of libraries for each language. One is called API and the second is SDK. API is basically the thing about creating metrics. SDK is more about sending the metrics, or telemetry. So it's about creating the pipelines. So you could internally use only the API, which is extremely vendor agnostic, and the SDK you can have some, for example, you can have some telemetry pipeline, which is, for example, suited for some particular vendor and has some batteries included. Then you have a protocol. There's something called OTLP, which is a protocol created for sending telemetry. So there is a protobuf basically, protobuf definition for the span structure and metric structure, and also for logs. The next thing is semantic conventions. So one of the more important things about telemetry is to have some standards. What this telemetry has inside. So how to create a span for an HTTP request? What attributes? How should I say that what is the root? What is the IP of the client? What is the IP of the server? So these semantic conventions allow to have to create dashboards, which will also can be reused between multiple vendors, because there's a convention how what data this telemetry should have produced. The next important component is called collector. Basically, it's like an agent that creates a lot of that can be used in between the backends, vendor backends, and the applications, which can process the data. So it can filter out some stuff, it can do sampling, and it can also have features that do not need to be implemented in each language. So especially SREs very like the collector, because they have one basically thing which they just configure. They just do not. They just say the application developers just send the data using OTLP. We'll use the collector to configure the telemetry how it need to be processed to sent to the backend. And the last thing is instrumentations. So basically, these are the libraries for languages and also tools that allow to emit telemetry. But there are also components which allows you to automatically instrument applications. For instance, for Java, there's something called a Java agent, which can be used to instrument data without any code changes. In .NET, they're using .NET Profiler. Even in Go, I will tell you later, there's an eBPF probe, which can basically get the calls from the Go code and emit telemetry based on the calls from the Go application. And at last, there's a Kubernetes operator who can do all of the stuff, meaning setting up collectors and instrumenting the automatic instrumenting applications. I know it was a lot. I just wanted to show you how wide it is, and that sometimes if you have some problems with generating collected with telemetry. You can even look inside the specification or web pages and try to find some answers. Maybe even if you're new to OpenTelemetry, you can find some interesting stuff there. So basically, the usual model of using like this is the usual way how SREs or basically systems are using OpenTelemetry. They're having some microservices which are using OpenTelemetry API SDK or automatic instrumentation. They're usually sending the data using OTLP to the collector. Sometimes the backends already have an ingestion endpoint to understand OTLP protocol. And then there are some observability frontends and backends that just can use this data to create dashboards or to emit alerts when something is going on. And there are also existing infrastructures which are out of the box producing OTLP telemetry. So Kubernetes, L7 proxy, I don't know what is it to be honest. There are also the Azure, also a lot of cloud platforms can also send their telemetry using OTLP. I know that Envoy was one of the first projects which is also sending OTLP data. Yep. So there's a similar drawing on these similar things, but this thing stresses one thing, that there are a lot of things which can be where you can use collector to process the data. So you can have multiple receivers. I was just telling about OTLP, which is like the standard way of serializing the telemetry, but the collector gives also possibility to also receive the telemetry using other like models. So, for example, Jaeger, or it can also scrape using the Prometheus endpoint, the metrics, etc. And then there can be processors and multiple exporters, which are also not OTLP. So there are, for example, exporters which can emit the telemetry back to the AWS and other different storages. Yeah, and also one of the backends is Stack Observability, which you can use instead of, for example, Jaeger or Grafana suite. And I'm really curious if my Docker is still not working. And this is very sad because that was one of the main points of my presentation, which I have no idea what's not working right now. No, it's not working at all. I just need to kill it. Do you have any questions so far? Excuse me? Docker. I really think it's about RAM. Because I remember that during one presentation I also had the same problem. It was also during Zoom sharing, and I'm considering I need to be. I think I need more RAM.
Good reason for upgrade.
Yeah. My manager is here. Yeah.
I have some in my pocket.
Very good.
No, this is production.
Yeah,
Just accept.
live demo. Next time I think I will record. Record.
You believe that if you kill Zoom,
I can try it on the end, but I do not want to do it now. So maybe I will try at the end. So just reorder things. Alright, so now is the second part about OpenTelemetry for Go. And this part does not require that much of RAM memory, so I hope it will work. So for Go, there are two ways of instrumenting the application. One is using the manual instrumentation, and this is the stable way. And second is automatic instrumentation, which is in alpha stage. So I will give you a teaser, but I will not demonstrate it. Especially as you see, I'm not a demonstration expert. So there are like there's a web page which you can use later on to learn how to instrument your applications. So if you can see here, there are like pages for getting started on instrumentation, libraries, exporters, resources. So there are nice web pages which will tell you how step by step do those things. But instead reading it, I will show you some of the things by example. So usually there are 4 steps. You have some applications, and the first thing which you need to do is to initialize the trace and metrics providers that will be responsible to send the telemetry somewhere to the collector, to the backend, whatever. So this is one step. One thing, it's only about traces and metrics here, because these are the only signals which are right now supported by OpenTelemetry Go. Logs are not yet implemented. Second bullet is you can use some instrumentation libraries, which can instrumentation library is basically a package, a Go package, which adds telemetry to some other package basically. So there are packages like OTel HTTP, which add traces and metrics to the places where you use net HTTP package. The third point, you can add manual custom spans and metrics. This is like a kind of important thing for observability when you add business spans or business metrics to your application. And fourth point, which is like with asterisk, is that you can create your own instrumentation libraries when you have, for example, multiple applications. When you use, for example, some library which is not widely known, you can also create an instrumentation library for it, so you can easily reuse it between your applications. And now, I will show you, and I hope this will at least work, a very easy application and how it can be a little system which consists of a CLI application, an HTTP service, and a database. Those two things are created in Go, and this is a to-do app, a to-do list app that you can simply create new to-do items, you can update it, remove it, and list it. So a very complex application that, very complex application. Yeah, I will get rid of this one, of this demonstration. Now second try, there will be no free tries. How is my time? It's pretty good. So as you can see, we have a very small two applications. Each of them is implemented in one file. These are especially written in a not very clean way, because usually when you deal with applications, they're never perfect. So for instance, you have one constant variable here, they are not used in context, etc. So this is just an application that works. It's not perfect, but it's effective because the most important thing, it works. So I will just Docker compose up. Alright. And I will have readme and show you. So I will split the window. Is it big enough for you? So right now I'm just building the to-do service, which is the HTTP service, and I have started it. And in the second window, I will build the to-do service. If it's working. So there's already something. So I can to-do add something. I can to-do add remove. I think it will be 5. To-do add and now we have some error. And when using like a traditional application, you can have problems identifying, for example, words. Like this is a very simple application, but let's imagine that this is a big application, very complex, when you have multiple, like distributed in multiple versions, and you can have problems identifying where does this come from to find the root cause of this problem. Here we have a log because I added, but let's imagine that it's something harder. So in order to get some more insight, I will close this one. And I have prepared a branch which adds OpenTelemetry, not check main, check out hotel. Compose down. Okay, whatever. I'm starting the service again. And I will reproduce the same problem. And right now, this thing has already some telemetry included, and I hope that right now at least these systems will work. So right now we have exported the data via collector to Jaeger, and we can see that we have a span that was there was an HTTP post, and basically there was an error. And we have even an information. So here we have instrumentation from the CL application. This is like the span created by the HTTP client instrumentation. Here there's a span created by HTTP server instrumentation, and here's a span created by SQL instrumentation. So we have an information that insert into tasks has a problem, basically emitted an error, and we have even a log, which is an event in OpenTelemetry, but it's called a log in Jaeger, that the value too long for the type character, basically that the value was too long. But also, we can have some metrics. So also, both of these applications are producing metrics which can be also, for example, scraped by Prometheus, and which can be then later utilized and create dashboards. And there's also like even a custom task count gauge, which even says that there is minus one task, is because basically I was restarting and playing a lot with the application. And the last part, I will show you the code changes that had to be done to add this telemetry. So remember these 4 points. Can I hide this on the left side? Is this big enough?
Yeah, you can on the left bottom. Left upper
This
corner.
one?
Yeah.
Thank you very much. So let's start from the first point. The first point was about configuring trace providers and meter providers. So here I created a package called hotel just to have these common things inside one package, because we are instrumented to applications. So we have only one exported function called run. And the first thing which you do when you're dealing with signals in OpenTelemetry is create a resource. A resource is basically like a static kind of representation of your application. It contains things like, for example, service name, service version. It can say you, for example, what is the host name. Even sometimes you can name, for example, your deployment. For example, is it production? If it's production, if it's tests, etc. So these are kind of metadata that will not change during the lifespan of the application. So in a lot of telemetry models, you often send the same data multiple times. In OpenTelemetry, you send the resources only one time in the batch. So when for example there's a batch of metrics or spans, you send the telemetry, you send the resources only once. And then the next thing so we're creating the resources. So basically each resource, the semantic conventions are also versioned. So one of the important things is to tell what is the semantic convention which we are using. And this is like also identified by the schema URL. The next thing, we are using a service name to say what is the service name that we are instrumenting. Next thing, we are creating the exporters. So here we are creating OTLP exporters for tracing and for metrics. Both are using HTTP for transmitting the telemetry. The second is gRPC. And then we are creating a trace provider. So the trace provider is like the SDK component, which is responsible then for gathering the spans and then emitting it using the trace exporter. And we are here saying that there will be batched. And we are setting a global set tracer provider. So basically globals seem like an anti-pattern usually, but the good thing about using global trace provider is that if you have instrumentation libraries, by default they are first trying to use the global trace provider. So by default it is a no-op trace provider, but if you register something, You just do not need to explicitly pass this trace provider to all your instrumentation libraries. The next thing which you are setting is it's a propagator. Propagator is the thing that enables you to have the context propagation. So you remember that if we go to Jaeger here, we can see that somehow we know that this span is correlated with this one. How is it possible? Anyone has any I don't know, someone has an idea how the telemetry knows that this to-do CLI request is connected with this one?
Because of context and data we have inside the context.
What context?
What we pass in the methods.
Could you speak out louder, please?
Because, for example, we have starting point of the application, and usually in Golang we pass the context.
But these are two applications.
Okay, there is some kind of the correlation idea for an ID.
The headers.
Yep. So this is the ID, and this is one thing. And the way how these IDs are generated is exactly what you are describing. This is give me a sec. So propagation trace context. So this is the way how this maybe not IDs, but how these IDs are populated to some places. And the second, also this is the correct answer. The HTTP instrumentation passes this information using HTTP headers. So both your answers are correct. So the trace context basically is one of the ways to set these IDs, and HTTP headers are basically used as an implementation specific thing for HTTP instrumentation. And the next thing, we are setting the meter provider, also with the resource, and then we are setting a metrics exporter that it will be that will simply periodically push the metrics to the OTLP. So basically OTLP has the push model that we are pushing the metrics.
And this is what I wanted to ask about.
Yes.
So when we are talking about the spans, so this is a push model, not pull like
Yes.
in Prometheus that we are starting
Yes.
metric. Okay, and how often is it pushed? So it's in real time, whenever you want to create a span or whatever.
It's batched, so we are using a batch processor,
Okay.
and
you
it's
define how
configured.
often it should be pushed, or
You can.
Yeah.
So there are options that you can pass to the you have it, as far as I remember, if you have this with batch here, I think it accepts. I hope. Yeah, you see, it accepts options. So it has this like gRPC option API pattern that you can pass multiple options. Probably if I probably we'll have so we have here. Sorry, but you can see that you have an export timeout, and the second I think is the interval. So you can define this. There are also environmental variables which can be used to set this. I do not remember if OpenTelemetry Go implements these environmental variables, but the specification says that there are some defaults which are used, and for sure the defaults are used here according to the specification, but also there you can set it using environmental variables.
and just out of curiosity, so this what I wanted to ask, if setting the traces or pushing is asynchronous, or
Yes.
it's asynchronous, right?
Yes.
So there is a request and
Yes,
okay.
exactly. So it's not blocking your request. But,
But the tokens may leak.
excuse me?
But we may have some leaks if there is.
Yes, of course. You can or leaks, or you can have some, not timeout. Like it will be not live, right?
Yes.
But you can use with sync. I think it's called in Go with syncer, and then it will use basically, as far as I remember, a synchronous span that it will.
Okay.
So there are possibilities here, but yes.
When you're batching, you also need to be prepared that some batches do not get to the OpenTelemetry because service died before it could send it.
If application dies, then yeah, it crashes, right?
So that's why this configuration is very important. Those batches may not be big, right? So you don't aggregate a lot of data and then you die.
So I think that by default, like I think that it's flashed like each 5 seconds or something like that. Later I'll also show a few other, or maybe one thing right now, because it's not only important for OpenTelemetry, but also for other things in Go, like just need to go back here. I will return to you if I forget when I will talk about the thing, I think, to-do service.
Okay.
Sorry, to-do CLI app. And I will return exactly to the thing because it will be a little easier for me and I hope for you as well. This is also related. The shutdown function. We need to make sure that when the application closes, we want to make sure that the telemetry is basically flushed. So the trace provider shutdown
function definition. Where is it? You pass it.
So I'm returning it. The API of this run is that you are returning an error and a flag, and the usage will be simply if there's an error. I think you get it, right?
Right.
You should usage later, but basically, if we set the providers, we simply configure that the shutdown will be basically about shutting down both providers. And if shutdown is called, it basically makes sure that all the telemetry is sent. You're passing a context, so you can set some timeout. That, for example, you do not want to wait longer than 10 seconds. But for purpose of this, I think I just use the background of this demonstration. And then here, I also added runtime metrics instrumentation, like additionally because I think all our applications would like to have some runtime metrics. Runtime metrics are basically metrics about the Go runtime, how many Go routines are there, etc. So I think there are also some CPU metrics as well. But
okay.
Yes.
I just have another question in my mind. Actually, if I would like to find how much of the resources, let's say, sending those batches are taking, what would be the best practice? Is that to me to just compare the resource usage of application that is not using only like that?
Always benchmark. And
there is nothing like golden standard or whatever.
No. There's no. Also, one thing, there's no golden standard. But your question is how much it should be, or how much is it?
No. I'm just looking for the best way to just compare to find how to probe the traces, right? Because we don't want to send every trace. But
there is something like you can have the center.
Yes.
And the configuration of the batcher in the center, you can randomize it because you can say, okay, send push the trace. Not for each request, but
so OpenTelemetry also defines different sampling strategies, and there are different sampling. I would say like implementations, which I can define by the specification. But just maybe one thing, like from my product, for example, with Splunk observability, we suggest and we allow pushing all spans. And basically, the product was designed in a way that it really handles high span ingestion. And also, it occurred that sampling is often more expensive. The CPU is more expensive than the storage. Nowadays, very often. It might occur that it's cheaper for you, even if you host your own telemetry. If you use, for example, Jaeger and whatever, it might occur that it's cheaper for you to store that much of data and, for example, have, flash them after, for example, 1 week or whatever, but, and not sample it on the applications because the CPU, it always requires CPU.
Okay. Thanks.
Any questions? And it's also about benchmark, you need to test it, right? Alright. So this is how this like common bootstrapping.
Okay. Maybe I can ask you another question actually.
Go on.
Because you mentioned something interesting before about events for traders, right?
Yes.
And is my understanding correct that those events are basically logs that you pass to the tool that you will use to visualize your span? It's just set of information like JSON properties that will be shown on the visualization tool like Jagger or whatever.
Kind of. Like it's not like the event is also a structure defined by the OpenTelemetry, which looks like a log. So the event, as far as I remember, consists of a body and attributes.
Yeah.
So and attributes, I do not remember if attributes can be structures deeply. I think it's just about one layer of depth in the event. I think that you cannot create like attribute of attribute, etc. But I may be wrong. I just never used it or never
But
needed
the
it.
main purpose for these events is just to give some more context.
Yes,
of
exactly.
what's happening.
Exactly. In theory, you could, instead of using events, you could use OpenTelemetry logs, which already have the trace
Take a
ID.
look at the logs.
Excuse me?
No, I'm just joking. Or you can take a look at the logs and see.
Yeah, but usually out-of-the-box logs do not have the trace ID and the
That's
span ID. And this is the thing which you have out of the box when you're using events, because it's correlating the event. And right now, for example, in AutoGo, you do not have the integration with OpenTelemetry logs. So you cannot use a stable way of producing a log with span ID. But you can do it using events. But this is the current state for today. Maybe.
We actually did that for logs because there's not a lot of log support, obviously.
Excuse me?
There's not a lot of log support at the moment through OTel. So because Go doesn't support it, for example,
Yeah.
either. I think. So we did that. We did something similar. So we just collect the logs and we add the trace IDs basically.
Yeah, we did
Yeah.
that same trace ideas,
So because we log every part of an ingestion pipeline, so we log everything, and because then we can trace the way
Yes.
through the pipeline, and it's always the same ID. So we basically, because it's not supported yet.
Yes. And it's easy to
We-
get the span
we
ID.
just did it
And
anyway.
it's easy to get the span ID and log it, right?
Yeah, basically we could also create a graph now for ourselves because it's just not supported. If you add it, that would actually be my question. Why is logging not supported? Because it's actually the simplest way of starting this whole thing. So why are all the libraries missing the log support here? It should be so simple to do. It's the first thing that I would start. You do the tracing is the more complicated thing.
The thing is, okay, that's a historical question, because OpenTelemetry was created based on open tracing and open census.
Okay.
And open tracing was a standard for tracing. I think open census was both on tracing and metrics. So basically, one thing is that they use things that which are already working, and also people who were involved were already had so much domain knowledge about this one that they feel a lot. Yeah, there's one thing. The logs was very also. It was not that easy, to be honest, because the specification is already stable. The thing is that they wanted to design a way that it will reuse the existing logging libraries. They didn't want to create a new hotel log library. They wanted to have a bridge API that you just simply use your logging library that you're already using. You just emit. You just add some. I don't know. You add some sync or what, I don't know. There are a lot of just some exporter or whatever, some endpoint to the logger. You just configure a middleware or whatever, and then it uses, for example, OTLP to send these logs to collector and send it back. So that's designed to not change the application code because logs are very, invasive.
Yeah. Okay. Understand.
Because logs are usually produced by the application developers, right?
Yeah.
Have I answered the question?
Yeah.
More questions? Go on.
Later.
Wow. I'm happy that you're asking questions because I'm so fed of the Docker Compose problems. And now I'm going to the next part. So how is it used? So one of the things which about not losing the telemetry, I think you're I hope you're listening. So one of the things that you can easily lose the telemetry is using OS exit. I'm not sure how much of you know that if you use OS exit, it basically kills the application. It doesn't call anything that is deferred. But often people who are creating applications do not think about this stuff because if something goes wrong, it can be crashed, etc. But it's not the same case for telemetry. if something dies, you want to have this important thing which may cause this failure. So basically, when adding the instrumentation, it often requires to make more code changes, which often results in better code, but it's something you need to invest. So, for example, one of the patterns to handle exit codes and make sure that things different are called are set at basically a variable for the exit code, defer the OS exit, and instead of using OS exit, just setting the exit code and return. This is just one of the patterns. I will not say that it is the best one. For sure, it's a readable one. And this is, for example, how the code must be changed in order to execute this shutdown function, which is returned by the auto run. So this is a to-do CLI service, and we are simply running the auto run, which I was showing before. And if everything goes correct, we are deferring the shutdown function. So this is like the first part about setting the traces and metrics providers. So we only bootstrap the pipeline. We also added the runtime instrumentation there, but now we are doing more. We need to instrument our application. So we are using now libraries. For instance, here's the instrumentation for HTTP. We are using an OTLP transport, and we are wrapping the default transport and create an HTTP client with OTLP instrumentation. So this is, for example, a way how to instrument an HTTP client. And I think for the to-do app, this will be all. Yeah, and another thing. Many people are not aware that even in the package, like I would say that it is a very common error. That people are not aware of this thing. A body must be closed even if it's not used when you're using HTTP. There are different reasons. As far as I remember, it's also about the HTTP, I think implementation, I remember correctly, has a pool of connections, and if you don't close the body, it will basically maybe not leak, but it will try to keep this connection as long as possible. So basically, even if you're not using an instrumentation library, you should close your response body. But it doesn't mean that people are doing it. So if you have some legacy application and you just add HTTP instrumentation, it doesn't mean that you will get produce the telemetry, because basically the telemetry needs to know when something has finished. And the only way how to know that something is finished for the HTTP instrumentation is to know that somebody called basically response body close. This is the place when the span ends for the HTTP instrumentation. So basically we had to fix errors by adding this different response body close or adding it in proper places as well. Because, for example, in some places they were wrongly placed. And now the second part is about, the more complex is about implementing a service. So, similar thing, we also need to handle somehow the shutdown. Originally, when you do not handle the interrupt signal, if you press Ctrl+C, it kills the application. Right? I think, right? So, if you want to make sure that the shutdown will be called when you're closing the application, you need to handle the OS interrupt, for example, if this is the way you're shutting down the application. So this is the one thing that needs to be changed to be sure that you do not lose any telemetry. So this is like the code which I created today, because I have not enough time, to make sure that when we are sending the interrupt signal, we are closing the application, and if it's not closed, then we are logging fatal. And apart from using more instrumentation libraries, so here there's an example of using OpenTelemetry, which is an instrumentation library for database SQL. We are also using metrics. We are getting spans, traces. We are also creating a custom metric. So here we are using the OpenTelemetry API to create a business-specific metric. We are creating an instrument. Instrument is a metric type, and this is an up and down counter, integer counter. And and this was the bug. And we are adding always -1, and when adding and when deleting. So this is why it was a negative number, if you remember correctly. Here it should be changed to +1. Oh no, this is -1. The other one should be +1. The other thing is that when you're instrumenting application, this and here the colleague said someone, I don't remember. Yeah, you said that inside the application the context must be passed, right? And this is true when instrument. If you do not pass, so the context is used by the instrumentation libraries to have the span context. So the span context is one of the fields which is passed as a value inside the context. So if you are not using the context API when using libraries, you will have detached spans. So if you remember this, basically this graph about when everything was inside, if you do not have this graph, basically you will have like not related spans if you do not use the context. So basically here, in order to have the database working, we had to pass to the we had to use the DB query context, exec context, and pass it from the HTTP. When there's the HTTP handler, when you get the request, you need to pass it down. Otherwise, there will be no correlation between the HTTP spans and SQL spans. Yes. And the last portion, probably, any questions regarding application, instrumenting the application?
I think I have one.
Yep.
What is the recommended way of naming span, for example? Because now we see only, the automatic created by HTTP, but we can create manually these spans. And we can set the name of the tracer and of these spans. What you would recommend, like, in which way? Because we can use the baggage and then the method name, but that is the best approach.
First of all, I will check if the specification has some recommendation, because maybe it has, which I do not remember, because unfortunately I'm writing instrumentation libraries mostly. I'm not, developing with business things, and I do remember those things by heart. But by practice, I think that usually you name the tracer when you have the business thing, right? You name the tracer like the name of your application or something, and you name the spans like your, for example, logic. For example, I don't know, create a product. It can be functionalized, but it doesn't has to be. Just use the things that are familiar for you. It's fuzzy, I know.
Yeah, because usually when you just use the business name, it will have similar names or equal names, for example, event handler, or event process, and you can have the same name for different spans, because that's why I usually like prefix.
Yes, you should prefix. You should definitely prefix. Because they should be unique.
Yeah, exactly. To
have, I don't know. I always remember high cardinality, low cardinality. I always mix the stuff, but it should be identified. It should be like unique. The span names, like similar for log messages. I think that also log messages should be kind of unique, right? To identify where where's the place where it come from, right? I remember that there's also something which might help sometimes, especially for metrics, because I think that also it is tricky how to name metrics. So apart from specification repository, there's a semantic convention repository. So this tells you what attributes to add how to name things. And I remember that recently they added even some conventions how the metrics should be named, but I think it will be here. I think it's the PR. Yeah. So basically, even the specification semantic conventions, there are even proposals about helping in the problems that you are telling. And also, the thing is that it's good to even, if you have some concerns, the community tries to be open and collaborative, and it's good to propose and share problems, because usually the problems are common against all the engineers. And this is definitely a common problem. And OpenTelemetry doesn't it has not only strict specification, it also consists of recommendations. And this is for sure one of the areas it should have more focus. It was a long response, but have I somehow answered yet?
Yeah,
It's already I'm out of time? 7 minutes, I see, out of time. Yeah. Alright, pizza is here. Time for pizza. I just I just want to tell you that the repository is here if you want to watch later. Here are some hyperlinks which can help you if you would want to do it yourself. 2 things which I have not covered. I have covered 2 things during this repository. OpenTelemetry GoCracow, which contains instrumentation libraries, exports, etc. There's also automatic instrumentation uses eBPF. It's in very early stage, but I know that there are even companies who are already recommending and using them. Splunk is not one of them, but probably it will work as well. And there is an OpenTelemetry operator, which is able to basically create, set up sidecars, collectors, and also agents, and even this eBPF instrumentation as a sidecar to automatically instrument your applications. And I know that this thing is loved by SREs. Not by application developers, but SREs love this thing. This is mostly about developers, it's about SREs.
May I ask a question?
Yep.
If you can go back to the previous...
This one?
No, the next one.
This one?
Okay, so this OpenTelemetry Collector instrumentation, what is it exactly? So it creates spans for the whole application, like every invocation?
No, we didn't agree on it. It basically creates for some instrumentation libraries. I think it's for HTTP, I think, and gRPC right now. I think it's only about those 2 libraries. So I think it only automatically instruments and adds spans for HTTP, for net HTTP and gRPC. I think only those 2, but I'm not sure. You'll need basically to check. I think also for Gorilla Max.
Okay.
But it's about checking here, and it's rapidly changing.
Okay.
So it doesn't create a lot of mess. And it also works with your manually created spans and metrics. Here are some QR codes if you want to, or you can make you can make a photo of this. You can here are the slides, and I would like, and here's anonymous feedback form. You can say that I hate that the Docker Compose has not worked for you. Shame on you.